Alright, so here's a quick video to go over the answers for the homework on page 388 to 396, questions 4, 12 to 16. So let's start with question number 4, where they ask us to balance the following equation. They give me a combustion reaction, and if you recall, when we balance combustion reactions, it really is best to start by balancing your carbons, followed by your hydrogens, and then finishing off your oxygens. In this particular case, you would need to put a 2 in front of the CO2 to get the number of carbons to be equal. You need to put a 2 in front of the H2O to get the number of hydrogens to be equal. And then if you tally up the number of oxygens on the right-hand side, it's 4 plus 2 or 6. So to get the same number of oxygens on the left, you put a 3 in front of the O2. The question then goes on to ask me to interpret the balanced equation in terms of relative numbers of moles, volumes of gas at STP, and masses of reactants and products. So in terms of moles, the coefficients basically tell you moles. So you need 1 mole of C2H4 to react with 3 moles of O2. You generate 2 moles of CO2, 2 moles of H2O. In terms of volumes of gases at STP, the coefficients also tell me what those values are. The coefficients can be read in terms of liters. So 1 liter of C2H4 requires 3 liters of O2. You make 2 liters of CO2 and 2 liters of H2O. In terms of masses, you might have to do a little bit of math here. 1 mole of C2H4, if it weighs 28 grams, and 1 times 28 is 28 grams. 3 moles of O2, if each mole weighs 32 grams, and 3 times 32 grams is 96 grams. 2 moles of CO2, if each mole weighs 44 grams, and 2 times 44 is 88 grams. And then 2 moles of water, if each mole weighs 18 grams, and 2 times 18 is 36 grams. The sum of the reactants on the left should equal the sum of the products on the right-hand side. Alright, so let's go on to question number 12 on page 391. On page 391, they asked me to look at this equation here. It was the equation from problem 11. It's 4 aluminum plus 3 oxygen yields 2 aluminum oxides. Part A asks me to calculate how many moles of oxygen are required to react completely with 14.8 moles of aluminum. Alright, so here's my fence post. Alright, so the first thing that I do is I write my given in the far left. I write the unit that I want to go to on the far right. Because I'm starting with moles, I have permission to go ahead and use the mole ratio. If I didn't, I'd have to do some work to get my given into moles before I could do that. The mole ratio would have moles of aluminum in the bottom. The reason why I want that is so that those units cancel out. It's going to have moles of the substance in the answer on the top, because I want to stop talking about aluminum, I want to start talking about oxygen. The numbers that go here in this conversion factor come from the coefficients in the balanced chemical equation. So the number in front of oxygen in the balanced chemical equation is a 3, so you put that in the numerator. The number in front of aluminum in the balanced chemical equation is a 4, you put that in the denominator. When I go ahead and insert 14.8 times 3 divided by 4 in my calculator, I get some answer rounded to 3 significant figures like my given. The answer is 11.1 moles of oxygen. For part B, they want me to calculate how many moles of aluminum oxide are formed from 0.78 moles of oxygen. So it's a very similar setup, but we have a new given. It's 0.78 moles of O2. It's a different substance that I want to go to. I want moles of aluminum oxide. But the nice thing about this question is that, again, I'm given moles, I'm ending with moles. If I'm given moles, I have permission to go ahead and use the mole ratio. So the mole ratio is going to have moles of O2 on the bottom because I want these units to reduce. It's going to have moles of aluminum oxide on top because that's what I want to go towards. The numbers that go here in this conversion factor come straight from the coefficients in the balanced chemical equation. Okay, so in front of Al2O3 I have a 2, so that number goes in the numerator. In front of oxygen in the chemical equation I have a 3, so that number goes in the denominator. If I do 0.78 times 2 divided by 3, whatever answer I get needs to be rounded to 2 significant figures. The answer is 0.52 moles of aluminum oxide. Alright, question number 13. Question number 13 gives me a reaction where I take acetylene gas and I react it with water. The products of this reaction are, calcium carbide and water to make acetylene gas and calcium hydroxide. So in this particular question, what they want me to calculate is how many grams of acetylene do you make if you start with 5 grams of calcium carbide. Alright, so first thing that I do is I write my given in the upper left. I write the unit that I want to go to in the far right. You'll notice that this unit that I'm given is not a mole. So the first thing that I have to do is convert it to mole. And the way that you do that is by dividing by the molar mass of calcium carbide, and you get that information from the periodic table. So if you take the mass of 1 calcium plus the mass of 2 carbons and add it together, you get 64.10. That would go in the denominator, 64.10 grams of CaC2. In the numerator, you place 1 mole of calcium carbide because that's the definition. When you pull numbers off the periodic table, that is the mass for 1 mole by definition. Once these units cancel out, the grams of CaC2, then you have moles. You're allowed to use the mole ratio. The mole ratio will have moles of CaC2 in the denominator because you want these units to reduce. You're going to have moles of C2H2 in the numerator. The numbers that go in front in the conversion factor are the coefficients. So in front of C2H2 I have a 1. In front of CaC2 I have a 1. They didn't want me to stop at moles, they wanted me to finish off in grams. So the last thing that I have to do is convert from moles of C2H2 back to grams. So the unit down here in the last piece of the fence post in the denominator is going to be 1 mole of C2H2 so that that unit can cancel out. And in the numerator I'm going to put the molar mass of C2H2 off the periodic table, and that's going to require that I take 2 times the mass of carbon plus 2 times the mass of hydrogen and add them together. And that mass ends up being 26.04. Once I'm done, in my calculator I'm going to do 5 times 26.04 divided by 64.10. Whatever the calculator computes needs to be rounded to 3 significant figures, and the answer for that is 2.03 grams of C2H2. Alright, question 14. They want me to use the same equation now to calculate the moles of CaC2 needed to react completely with 49 grams of water. Alright, so in this particular case, same reaction. My given is 49 grams of water. This is still not a unit that I like to see at the beginning of a fence post. So the first thing I'm going to have to do is convert it to moles. And so in order to do that, I'm again going to use the periodic table. I need to divide by the molar mass of water from the periodic table. So if I take 2 times the mass of hydrogen plus 1 times the mass of oxygen, I get 18.02 grams, and that's the mass in 1 mole by definition. So you'll notice that the units in the upper left and the bottom right cancel, and now I'm in moles of water. Now that I have moles of water, I can use the mole ratio to convert from water to calcium carbide. So in the bottom down here in the mole ratio, I'm going to put 2 moles of H2O. The reason why there's 2 is because the coefficient in front of H2O in the chemical equation is a 2. In the numerator, I'm going to put 1 mole of CaC2 because I want to start describing this particular substance, and the coefficient in front of CaC2 in the chemical equation is a 1. At this point, I can stop. I don't have to continue with the fence post because they wanted the answer in moles, so I'm done. So on my calculator I would do 49 divided by the product of 18.02 times 2. And I rounded to 3 significant figures, I get 1.36. Alright, let's take a look at question number 15. Question number 15 gives me a new reaction. In question number 15, I have 2 moles of potassium chlorate decomposed to give 2 moles of potassium chloride and 3 moles of oxygen. They give me 6.54 grams of potassium chlorate, and they want me to calculate molecules of oxygen. So I'm going to write my given in the upper left, what I want in the far right. Okay, so first things first, let's take this one step at a time. This is not a unit that will allow me to use the mole ratio off the bat. I have to convert this to the mole first. So the first thing that I'm going to do is I'm going to divide by the molar mass of potassium chlorate. That's calculated from the periodic table. So you take the mass of 1 potassium plus 1 chlorine plus 3 oxygens and add it together. That's that value right there. That goes in the denominator. In the numerator you write 1 mole KClO3 because that's by definition. When you pull a number off the periodic table, that's for 1 mole. Alright, so you'll notice that these units that are catty-corner from one another cancel out. Now I'm in moles of KClO3. Once you're in moles of KClO3, you can use the mole ratio. So in the mole ratio, you would have 2 mole KClO3 on the bottom. You want these units to cancel out. The reason why you put a 2 in front is because that's the coefficient in front of KClO3 in the balanced chemical equation. In the numerator, since we're changing it from KClO3 to oxygen, you would put 3 moles of oxygen. Alright? Now, the issue though is that they didn't want me to stop at moles, they wanted me to go on to molecules. So if you remember the flow chart from chapter 10, to go from mole to molecule, the final step will require that you multiply by Avogadro's number. So this last piece of the fence post will have 1 mole of oxygen on the bottom so that these units can cancel out, and in the numerator you're going to have 6.02 times 10 to the 23rd molecules of oxygen, because that's by definition how many molecules there are in 1 mole. So on the calculator you would do the product of the numerators divided by the product of the denominators. Whatever your calculator spits out should be rounded to 3 significant figures like you're given. And the answer for 15 is 4.82 times 10 to the 22nd molecules of oxygen. Alright? Be very careful that when you read these numbers off your calculator that you read all the way to the far right to see if there is some sort of exponent that you should include in your answer. I would anticipate that a lot of you guys would just write 4.82 and forget to read the times 10 to the 22nd. Please be careful. Just read all the way to the far end. Alright, last question, number 16. 16, I have this reaction, 3NO2 plus H2 yields 2HNO3 plus NO. They tell me that I have 5.00 times 10 to the 22nd molecules of nitrogen monoxide, so I go ahead and write that in the far left. And they want me to change this to grams of nitrogen dioxide. Alright, so again, first things first, I look at this given, it's not a mole. I have to change it to mole. So if you remember the flowchart from chapter 10, to go from molecules to mole, you have to divide by Avogadro's number. So in this first piece of the fence post, I'm going to put Avogadro's number in the denominator so that that unit in the given is canceled out. And in the numerator, I'm going to write 1 mole of NO. Now that M, in terms of moles of NO, now I can use the mole ratio from the balanced chemical equation. So the denominator in the mole ratio will have moles of NO so that those units can cancel out. The coefficient here in front is a 1 because, the number here in the conversion factor is a 1 because the coefficient in front of NO was a 1. In the numerator, I'm going to put moles of NO2 because that's the substance that I want to start talking about. The coefficient in front of NO2 is a 3, so that's the number that goes here in this conversion factor. And then they didn't want me to stop at mole, they wanted me to continue on to grams. So the last thing I'm going to have to do is go from moles to grams of NO2, and the way that you do that is by multiplying by the molar mass of NO2 off the periodic table. So if you take the mass of 1 nitrogen plus 2 oxygens and add it together, it ends up being 46.01. You would put that in the numerator. In the denominator, you put 1 mole of NO2 so that these units cancel out. You take the products of the numerator divided by the products of the denominator, and you write your answer to 3 significant figures. The answer that you get is 11.5. Alright, so that's essentially your homework. Make sure that you understand everything that you did because you will have a quiz when I return. I will leave the answer key for the substitute in case someone wants a little bit more time to look at it in greater detail. But at this particular point, you're going to work on a Sage and Scribe. So you're going to have to sit in partners, sit in pairs, and one person is going to get worksheet A. So person 1 will get worksheet A. It's listed on the upper right-hand corner of the worksheet. Person 2 will get worksheet B. And you guys are familiar with how Sage and Scribes work. One person gets the odd number questions, one person gets the even number questions. You can choose to either take turns, go back and forth, or you can choose to do problems 1 and 2 at the same time and then check each other's answers, and then move on to questions 3 and 4 and check each other's answers, 5 and 6 check each other's answers, 7 and 8 check each other's answers. You can write on these worksheets, you can keep them. You really need to master the things on this worksheet because this is essentially your quiz. If you have any questions, please feel free to email me. I will be in on Thursday, and I will be available Thursday afternoon in case anybody needs any help. Okay? I'll see you Friday.